Hello. So this time we have an application of systems of linear equations to a problem of partial fractions. In, so I'll proceed in this fashion. Suppose that you're interested in computing the following integral. Right? Of course, what the partial fraction decomposition says is that this might be written in the following fashion as an integral of a over x plus bx plus c over x squared plus 4 dx. Now, the thing is the following. Once we solve it in this fashion, uh, essentially the problem is no longer a problem of calculus, right? Of that of finding the antiderivatives, because the ones that are associated with these forms are well known. Really, the question is, how do we find these coefficients that allows us to express this particular fraction? In other words, now we need to find a, b, and c such that we have 1 over x times x squared plus 4 is equal to a over x plus bx plus c divided by x squared plus 4. Well, now, the x doesn't have an intrinsic meaning. It's just a placeholder. It's a symbol, right? So we'll treat it in such a way. What we're going to do is expand this a little bit. Say, well, instead of having this, I'm going to express this as 1 being equal to a over x plus bx plus c divided by x squared plus 4 times x squared plus 4. Once we do that, well, look, this equation now transforms into this particular format. 1 is equal to a times x squared plus 4 plus bx plus c times x. And of course, we now can turn this equation into an equivalent one that looks like this. We have 1 is equal to ax squared plus a times 4 plus bx squared plus cx, right? Which now we can rewrite in turn as 1 being equal to a plus b times x squared plus c times x plus 4 times a, or a times 4. But then look, what do we have here? Well, here we have a polynomial expression in x. In here we also have a polynomial expression in x, but it's kind of hidden. It really looks like this. 0 times x squared plus 0 times x plus 1 is equal to a plus b times x squared plus c times x plus 4a. But then what does this mean? Well, that really means that, well, the quadratics should match the quadratics, the linear should match the linear, and the constant should match the constant. In other words, I should have that a plus b is equal to 0, c is equal to 0, and 4a is equal to 1. Now, we may use matrices or any other device that we use to solve linear equations, as this is simply a set of linear equations, right? System of linear equations that needs to be solved. But then look, small manipulation of this leads us to the following. We have a plus b is equal to 0, c is equal to 0, and a is equal to 1/4. And from here, we can read off that we have that b is equal to negative 1/4, c is equal to 0, and a is equal to 1/4. So we have 1 over x times x squared plus 4 is nothing else but 1/4 times 1 over x plus, well, negative 1/4 times x plus 0 divided by x squared plus 4. And if you want to write it, this is 1/4 times 1 over x minus 1/4 times x over x squared plus 4. And of course, if you want to solve the original problem, well, this one corresponds to a logarithmic integral, and this one also, right? As you can simply proceed by substitution. Okay, so I hope that you like it. Take care.